Magnets are fascinating objects that have captivated the human imagination for centuries. Their ability to attract certain metals and their mysterious, invisible force fields have made them subjects of wonder and study. Magnets are objects that produce a magnetic field, an invisible force that can attract or repel other magnetic materials. This field is generated by the movement of electric charges within the magnet. The most common magnetic materials are iron, nickel, and cobalt, but alloys and compounds of these metals can also exhibit strong magnetic properties. The science of magnets lies in the alignment of tiny magnetic domains within the material. In unmagnetized materials, these domains are randomly oriented, cancelling out each other's magnetic effects. When a material becomes magnetized, the domains align in the same direction, creating a cumulative magnetic field. Magnets have two poles, north and south. Opposite poles attract each other, while like poles repel. This fundamental principle governs the behavior of magnets and is the basis for many of their applications. But have you ever wondered on how they are made? In this video, we will explore the intricate step-by-step process on how these magnificent metals are made. Magnets come in various types, each with unique properties and applications. Let's explore some of these types. Permanent magnets. These magnets exert a force on objects without any external influence. A classic example is magnetite, iron ore, also known as lodestone, a natural permanent magnet. Permanent magnets can also be manufactured by subjecting certain materials to a magnetic force. Once the force is removed, these materials retain their own magnetic properties, although these properties might change over time or at elevated temperatures. Electromagnets. These are created by surrounding certain materials with a coil of wire. When an electric current passes through the coil, the materials exert a magnetic force. When the current is shut off, the magnetic force drops to nearly zero. Electromagnetic materials retain little to no magnetic properties without an electric current flowing through the coil. Creating magnets from alloys is a detailed process involving several critical steps. Here's an overview of how it's done. For alnico magnets, primary constituents are aluminum, nickel, and cobalt, with additional elements like copper, iron, and titanium. The proportions of these elements are crucial as they determine the magnetic properties of the resulting alloy. The raw metals are cast into molds, usually made from sand, which can withstand high temperatures and is cost-effective. The process begins by creating a sand mold of the magnet shapes. They load the pattern of magnet shapes into a machine that fills it with sand. Once the pattern is filled, it's removed from the machine and the surface is smoothened out, removing any excess sand from the top. The sand mold is then chemically hardened by pumping gases into it. After forming and hardening the sand mold with gases, it's ready for the molten alloy. The selected metals are placed in an induction furnace, reaching temperatures around 1600 to 1700 degrees Celsius, 2900 to 3100 degrees Fahrenheit. The molten mixture is poured into the sand molds, which may burst into flames due to the previously used hardening gases. The molds are cooled down, often by breaking them open with a sledgehammer, allowing air to penetrate and reduce the temperature. This step is essential for establishing the alloy's microstructure, influencing its magnetic characteristics. The cooled pieces are separated using a magnet. Initially, these mold pieces act like ordinary metal because they haven't been magnetized yet. They undergo heat treatment in an electrical furnace and are then mildly magnetized using an electromagnetic coil. The pieces are set in an electrical heater and are then somewhat charged utilizing an electromagnetic loop. After this underlying charge, the pieces are additionally polarized by putting them between the shafts of an exceptionally strong electromagnet, adjusting the attractive spaces inside the composite and giving an extremely durable polarization. It is then embedded into an alternate electrical furnace that boats its heat until it is scorching as this prime to acknowledge electroattractive fill, which will be conveyed by this metal bar. They slide it down into the copper line and applaud it I place. Water holds the line back from softening as they convey a low-voltage high ebb and flow charge, and barrel-shaped development educate regarding a liquid magnet. They tear open the substantial seal. The interaction have left the ring somewhat charged. In any case, above all it arranged the attractive fill appropriately. They grind away the harsh edges, keeping it smooth and neat. Right now these magnets are really futile, yet this machine will enable them as it conveys an electro-attractive charge to the metal which polarizes it. The foundation of that feeble attractive field before resembles the amazing work for this second, guaranteeing that the polarization is appropriately situated. The finished magnets undergo thorough quality control checks, including magnetic property analysis, dimensional inspections, and visual assessments to ensure they meet industry standards and customer requirements. Magnets are more than just toys or tools, they are a gateway to understanding fundamental principles of physics. Whether you're a curious beginner or a seasoned scientist, there's always something new to explore in the world of magnets. Their invisible forces connect us to the mysteries of the natural world and drive technological innovation, making them truly extraordinary.